So the idea is the cons are there. At the end of the day, a machine is a machine, and a human is a human. uh, there are aspects like emotions, and then there are aspects like what to say, correctly correlating something, which sometimes the machines can do, and sometimes the machines cannot do as well. So these are all some kind of a cons which come into picture, but the world is looking more on the positive side of how AI is being used to advance in their day-to-day activities. So that's the part we'll mainly try to see. This kind of figure is pretty much common nowadays. Everybody is feeling that AI is going to take away a lot of things of humans and going to be replaced by these robots, but nothing so very scary on this. It is going to be a lot more humans as well, everywhere, as well as using these machines. So in general, what is AI? It is a simulation of human-like intelligence in machines. So what we are trying to do here is, like, over the past years, a lot of people have understood that there are many tasks which are repetitive in nature. For example, yeah, if we can have an automation of those tasks, that might even out people's works. That was one use case or a scenario where people felt that any involvement of machines can help in fast tracking some of those and bringing more accuracy. Because if you are asking a human to do a particular task, if he does the same task again, there is a chance that even the human can make a mistake. But if you are asking a machine to do it, there is a chance that it might do in the same way what it did the last time, because it is only following the instructions and delivering it. So these are some examples which have kind of led to a scenario where a lot of technology geeks have realized that we need to maybe have a look at how machines can help us. That was where AI started to come in. AI includes machine learning, so that is you train the machines to understand what task it needs to do, and then you test it as well. So if you have a huge set of data which you want to be utilized in your AI system, you will use part of that data for training the system first, the AI system first, and then use the same set of data, a part of it, to test it as well, whether it is really giving those results what you are actually desiring or not. And then you try to implement that AI system depending on the accuracy at which it is able to deliver the task. For example, if you are asking a question and if it is answering in a correct way, that means that it is working well. If it is giving a wrong answer, which you know is a wrong answer, then that means that it needs to be retrained for a again, or a little more with a more detailed way of explaining to the AI system on what it needs to do. That's the whole idea in which machine learning comes into picture. It's used it is used in everything from voice assistants. You must have seen IVRs and all these. They are repetitive bots, chatbots, or AI agents who repeatedly do those tasks. So it is already in use in some places. To medical diagnosis, wherein some precise identification of like disease is also an advanced level of AI use case in the healthcare sector. Or self-driven cars, you must have seen a lot of self-driven cars which are no, there is driverless cars who are actually just maneuvering and managing with working with the Google Maps or somebody like that and trying to navigate their way. So a lot of examples are there where AI has automated a lot of these tasks. The levels of automation, if we see, like, have evolved over time. In level one, we used to have typically something called as the bots, which is the remote process automation. They used to be bots who used to do some tasks, whatever you are telling it to do, and then it used to do those tasks. And then a business process management. That is, business process management, BPM, is more like you have a machine do some part of it, and then finally some human has to approve that. For example, if it is a banking application, you can have an AI system ask the person the questions and fill the form, but a human actually approves that loan application or whatever it is, and then it goes into the system again for the AI system to take it further. So that kind of a thing is called a BPM, business process management. Then you had this concept of generative AI which came in, which is more like prompt based. That is like you ask a question, it will do a search of all those answers and all that and bring you back the most accurate answers to you. So that is another level in which generative AI used to be utilized for, and it at the back end it uses something called as a large language models. So these are huge sets of data and metadata which have the details of what an answer for a particular question will be. So like it can be a simple question like what is the color of this mango. The AI system will do a search of one of these LLMs, or there is also something called the SLM, that is small language model, and then give you the answer. So that kind of a technology, generative AI, was hugely used. The advantage of that was it could help not only return back to you as text, it could generate images. It could give it in the form of a pictorial aspects as well. So these are some things where generative AI came in. Then you had a next level wherein non-generative AI agents were also part of it. That is, they not only do some what to say RPA works, which is like assistants who respond something, but they also like kind of like a help in answering something based on some basic intelligent questions. If we have fed them those questions and answers, then the level 4 was more on agent builder for basic agentic AI. When we say base agentic AI, here it comes a little bit of an intelligence system wherein it uses past data, understand the scenario here, and tries to give the answer by itself also. So it is more like a little more autonomous. And it can be in the form of a semi-autonomous, that is somewhere in between the humans are intervening again, or a fully autonomous agentic AI like this, for example, the self-driven cars. I mean, it is running everything by itself. It doesn't need anything to do. The actors are somebody like humans, RPA bots, AI-powered agents, semi-autonomous agents, and fully autonomous agents. Then where did this all start from? The history of artificial intelligence, somewhere in 1950s, there was a gentleman, John McCarthy, who coined the term artificial intelligence. And then there was some early achievements and setbacks because a lot used to happen on data and analytics part during the last few centuries. Then eventually all of this was put to use in a machine learning and data driven approaches to arrive at some things. Then there was a boom in 2000 and 2010s, wherein not only the machine learning parts, but also deep learning or neural networks, where this advanced level of agentic AI kind of a thinking, what it can think more like humans, those aspects started to come into picture. And today's time, yeah, it's more on the generative AI as well as agentic AI parts, which we have seen right now. That's how it is. I mean, this is a pretty text slide. It gives a difference between general AI, generative AI, and agentic AI. By definition, that simulates human intelligence, subset of AI focused on creating text, images, and code. Even for developers who are actually working on developing code, generative AI can generate some code for them actually. So that's been a very, very advantage for many developers. Agentic AI takes it to the next level, capable of decision making and actions. That's where the agentic AI comes. We'll not go deep into this. Then again, a pictorial view of, you can see a transitional AI and an agentic AI where literally AI agent or a bot is sitting there and doing most of the tasks of what a human used to do. It is making life easy in some cases, but yeah, it is surely scaring a lot of people whether some of the jobs are at risk if everything is done by this agentic AI or automated bots. So I'll pause here and maybe Tushar can talk some few things what we are actually missing in the overview of AI.
I've got my own presentation, so once you finish, then I can.
That we can do that. Let's do that then. Yeah, general challenges and guardrails for AI. This is something what we thought we'll cover. Is it this slide? Yeah, general benefits. Let's start with the benefits. Typically, automation of repeated tasks, data entry, and all of these, improve efficiency and productivity. Like it, for example, reduce time taken to process documents. If you are doing a loan processing, it does scan thoroughly, quickly, and then makes you help take decisions fast. Improve accuracy and error reduction. Critical tasks like medical diagnosis, financial forecasting. It does a lot of deep insights of past data and then gives you an accurate forecasting. Manufacturing quality control. This is a very, very useful one if you are developing something in a manufacturing industry. All those manual quality checks which used to be done, they can be automated by using some of the AIs. So that is a very important area, so that like the product is actually coming out in good quality. Help in decision making and insights, to uncover patterns and trends in real time. So this is something more around the agentic AI part, decision making and insights. Perform dangerous tasks. You can utilize AI, robots or bots to do some tasks which are very much not in the interest of human safety. For example, deep inside mines or search and rescue operations. You can program it and ask it to do those tasks like bring those material or the humans who are stuck there from this particular AI bot itself or whatever it is. You can ask it to do those. Handle radioactive substances in inspecting hostile environments which are highly chemical oriented. If you want to inspect those, you can utilize those. Advanced diagnostic and scientific discovery, disease detection, scanning 30 times faster than humans. So it does a lot of processing, much more than what sometimes humans can do. The point here, again, I'd like to pause here is there is a person who's been doing the task and he knows that particular task very well. Here, if it is a repeated task, then an AI might be useful. But if it is something what has to be thought, maybe at that point the human is a better person than this robot or a AI bot. So that decision of what is to be used, either an AI system or a bot or a human, has to be done by the system implementer. What is more advantageous at that point of a time? Yeah. So these are some aspects. Cost saving, yeah. I mean, it reduces operational efficiency, labor cost. This is a little bit of a debatable aspect because if everything it can do, then maybe there's going to be a job loss or something like that. That's the scare which the world has as well. Yeah. Improved forecasting to identify new patterns, dynamic, reliable, accurate forecasting of supply chain. So in your retail industry, if you have your inventories, it can actually track what is low in inventory, give an alarm to the team to make sure that the inventory is replenished again, so that like it can continue the production, the sale of those retail products. Otherwise, I mean, warehouses is a classic example. If you see a warehouse, always inventory management, transportation from warehouse to the retail stores, these are some classic examples where you will find some use of AI in managing those supply and demand aspects. Weather, what to say, trends. I mean, most of the weather industry, what to say, use AI in some way or the other to understand. And it has a lot of integration into IoT, which is Internet of Things objects also. Like your devices which are actually making the weather forecast, AI can tag on to that and analyze the past data of what was being the weather and what is possible weather in this month or this time of the year, and how is it different today when compared to last year. So all of those analysis it can do. So the weather forecasting can be made a lot more accurate. Environmental sustainability, yeah, I mean, like it can optimize your data centers. A lot of data in today's world is in data centers, like all across the world. They consume a lot of energy actually. So an autonomous system can actually see if there are lot many people, then the lights will be on. If there aren't a lot of people, then it will reduce the number of lights. So like it can do that automatic control of energy consumption in the data centers, agriculture crop yields. Even in agriculture sector, there is a huge scope for it to be like improvising some ways of crop yields. And climate modeling we discussed already. Now, the drawbacks, what we see are the AI workforce. We are creating a lot of AI agents and bots which people are using. So there can be a big complex set of these robots which might lead to chaos. So that is one of the first thing. Then it is the second one is who is accountable for these decisions of these people. That's the next question. Who is accountable? They are all making some actions. All these AI systems are making some actions. Who is responsible for it? The AI itself, or the person who has created it, the developer who has created it, or the implementer who is purchased it and using it? So these are some questions which are coming up. Scaling agents in a reliable requires more experimentation. AI systems usually need a lot of training, actually. If you notice what I talked about, training and testing, there are two parts to it. So when you build up an AI system, first you will have to train a lot with lots of questions and how it will answer, and then you will have to test it as well. So that can be a little bit more costlier. Unlike the previous generation built on cloud, these are powered by data, machine learning, and autonomous agent. So, like what has already been built on cloud databases and web interfaces, while it uses all of these, but the way it is done using vectors and all of these aspects to get the responses as an AI system is a lot different. So again, here there is a change in the way in which it is handling data, boost in productivity and efficiency, but realizing uh, the benefits require some infrastructure advancement, which is similar to or related to what we saw previously. It needs a little more investment in trying to see how best you can get the things. And AI is entering its third wave from predictive to generative to agentic. Safeguards like adversary testing and spotting biases, security risks, these are coming into picture nowadays. So if you see, the bias is a very important aspect. That is like it might have been trained in a particular way, but that may not be true applicability. So while training, you tell that like if this is the question, your answer should be this, but in reality, the actual answer should have been something else, or it should have been an unbiased answer. So this is a scenario which does strike a lot of debate in today's world. And yeah, security risks, like how it can leak, or how data protection can be done using AI systems. That's another aspect which needs to be taken care. And it needs a large volume of quality data. This is again related to this. As I told, it requires a lot of training and testing in today's world to manage it. Now, what I will do is I will pause here. I'll come back to this part after Tushar completes.
Thank you, Sarang, and thank you everyone for the opportunity here. So I think what Sarang was doing, I think he created a slightly underrated picture of what AI is doing. So let me take us.
He'll take it to the next level.
Yeah, no, I'll just take to the other side and I'll tell you why I believe that it's actually the inflection point and why what's happening right now is once in 100 years, probably even more of a thing, how it's creating that societal disruption. Just to create that picture, on the top of what Sarang has mentioned. Very quickly, my introduction partly been given. So my name is Tushar Srivastava. I'm the head of AI and quantum computing at TechM. Before that, I was an entrepreneur. I ran a startup in health tech, another one in space tech, have chemical engineering from IIT, MBA from University of Oxford and University of Bristol, quantum computing. I've been working with AI for last several years and seen its journey, which is why the deep belief that I have. But let me, so the idea here is I thought I'll take a step back and explain that what's been happening over the last 70 years in the whole field and why now is the inflection point. Because a lot of people feel that, it's been going on for a while, nothing had happened so far, so why now? So just taking a step back, right? So even in India, right, when we have any scientific principles and everything, we try to link it back to our Vedas. And that's the same thing that we do over here in Western country. We try to link it back to the Greek or the Roman civilization. It's actually quite fascinating that a lot of ideas that we have were actually being developed, these 2,000, 3,000 years ago. And I actually find it very fascinating. So, for example, the whole idea of that the world is made up of fire, earth, water, and so on. So that was the Greek idea. But Democritus, who was the first one to think that it was atom, that everything is united by this one thing called atom. So in some sense, he is the first particle physicist, right? That the modern particle physics theory started then. Similarly for AI, I don't know, can somebody guess? It's actually there written somewhere, but it's visible, right? Yeah. Someone know who that is? Yeah. So Aristotle was the first one who in some way started to think about the idea that what if we can build machine which can obey humans and do their jobs. And that's how the thinking kind of started. Although it's another matter that he didn't think of AI in the sense of AI today, he was thinking more about the slavery, right? That how people were using humans to do the slavery job, and he thought if machines can do the job, then there'll be no need for slavery, there'll be no lords, and so on. So the noble idea, so that's where the whole kind of thing started. So the real AI in 1900s kind of started with this person. Again, a question. I'm just trying to keep it engaging. So anyone knows who that is?
Alan Turing.
Correct. So Alan Turing, any of you have watched the movie Imitation Game? That's actually one of my all-time favorite movie. He wrote a paper computing. So that was called the Imitation Game. The movie was called Imitation Game, although it was nothing to do with AI. It was with the World War II and the Enigma. But his actual paper, Imitation Game, was about AI, in which he did this. He laid down the mathematical principles of what a AI or a thinking machine might look like. And many of you might have heard of the test called Turing test, right? What that is that if I ask a question to a human and a machine, which are sitting behind a curtain, and their response, and I can't figure it, I can't distinguish which came from the human or the AI, and that would be the time, and that will be the machine that will be AI, that I can't make the distinction. I feel actually we have actually surpassed that, because now I can tell it's come from ChatGPT because it's so good. So I want to take a step back again, and this slide kind of encapsulates that why you should start to think that why this is the inflection point, what is happening, why it is deeper than some of us might want to believe. So over the several last 200 years, 300 years, humans have been trying to solve human skills. The first skill was the physical labor, right? How we do physical jobs, farming, machinery, and so on. And in the Industrial Revolution, it was that physical skill that we had to offer was being automated, and that was the early humans. Sorry, not early humans. Human solving now the early human skill. And then a lot of time people think that okay, fine, information technology came and that's been there for a while. But what's been happening then is that the only human skill that it actually solved was computation. If you think about computers, all they do is calculation, right? If you're rotating images, it has got no idea what's doing. All it is doing is some matrix multiplication and so on and so forth. And then over the years, the only thing that has been happening is that the form factor, that how we consume this computation, whether through iPhones or a PC in the past, or how the computing has been done, whether it was a mainframe in the past to cloud today, but it was all about computing. So that's the whole innovation that was happening. And in some sense, the skill that we solved about our own mind was the computation. And what humans started to do after the Industrial Revolution, they started to move more toward the cognitive parts, right? So where they started to do more of how to operate the machine, right? Where the human mind was involved. But these machines were not intelligent. At this point, we started to automate some of the computation part. But then what's been happening recently, when I say recent, it's actually the last 50, 70 years history, is what about the rest of the cognitive skills? What about our other skills that we have, reasoning, cognition, planning, language, creativity, abstraction, and so on. So again, when the computer started to come, humans started to move more toward these type of skills, right? Where we build algorithm, we do creative work, we do process design, and so on and so forth. But not the computation. The computation part is done by the calculator. We build the algorithm, we tell the computer these are the steps, and it just executes it. But what about these other skills? And the question or the thing that I want you to think about, and this is where I'm taking a different stance here, is that what if we could solve these skills as well? If we do solve these skills, then as a human or as a society, what do I have to offer more, which a machine can't do? Although we may have our own opinions, whether we are here or not, but that's the key question that we need to think about. So again, so this is the part I want to focus on. Obviously, most of this you're already aware of. So a very quick history here is that there were three different paths which from 1950s that the scientists have tried to follow in trying to solve the cognitive skills of human. The first one is about where they try to actually simulate the human reasoning path. And this picture is from Dartmouth conference, and Sarang in his talk said a name who coined the term, and maybe it's a question, a test question. Who was that name? The person who coined the term AI. He's
John McAfee.
Yeah, correct. So John McCarthy is one of these people. So they met at Dartmouth conference. They coined the term. But as you can imagine, while it sounds like a good idea that I'm trying to somehow simulate what human reasoning looks like, it actually is very hard because human mind can work in many different ways. In fact, all of us who sitting in this room have very diverse way of thinking. So to simulate that was a very hard job. It was the early start. Maybe it got the early traction as well, but didn't really succeed in the long term. The other path was to actually explicitly build all the rules, just put all the calculations, all the decision algorithms, and so on. And this you may have seen in 1990s, 1995 or so. I can't remember exact date when Deep Blue defeated Gary Kasparov. But that's just a supercomputer doing brute calculation. There was no reasoning. There was no cognitive skill there. Again, this worked fine in the early days, but later on it didn't go any further because I can calculate chess moves, but I can't really simulate how human creativity works and how I solve different problems. The third path was that, okay, fine, if I've got these algorithms which simulates my brain, like the neural net structure, the guy called Marvin Minsky, and there were several other names who were involved in this. They said, okay, I can't simulate all of that, but what I can do is to let the machine learn itself. That is, I just get a different situation, I give it a lot of data, I give it data and the answer, and let it learn itself. A bit like a child would learn, right? A child figures out its own world by himself. In the beginning, it doesn't have an idea. If I throw a handkerchief on some object, it doesn't know that the object is still there. But slowly, it starts to figure out, it starts to learn, start to make distinction between colors and so on. Anyway, the key idea is that just the human learns, I give it data, and it starts to learn as well. Now, this was the least popular in the beginning because how do I make it learn, right? What is the algorithm? And there was no real breakthrough over there. So it didn't take off in the very beginning. Spoiler alert, so or you may already know, this is the field that is explored now. This is the field that's making all the difference. Anyone of you from IT industry? So you guys would probably have a good idea about this. So what has happened over the last 75 years is that in the beginning, so this is that third lane that I'm explaining a bit more. So in the beginning, there was a guy called Frank Rosenblatt around 1956 or 57. He came up with an algorithm that you can actually train these machines, these perceptrons. But the only thing it could learn is to draw linear functions. So for example, people here plays flute, people here plays harmonium. It can learn that, okay, if I draw a straight line, people here are flute players, people here are harmonium players. But then somebody proved that they can only learn linear functions, meaning they can only draw straight lines. But obviously the world is not like that. It is possible that people in the back row are the flute players, people in the front row are the harmonium players. So I need to make a line which goes like this. That's a non-linear function. So what happened, many of you may have heard of a guy called Geoffrey Hinton, who is now called the godfather of AI, and you can look him up on YouTube and watch a lot of his videos. And he might be giving even bleaker picture of what I'm giving. As to what AI can do. But anyway, so he came up with the algorithm called BRACPROP that actually was the mathematical foundation of how you can train these models. And there was another guy who came up with a mathematical proof that these neural nets can learn any function. Now this is very crucial, very deep, because it means that anything that a human can do if I think of it as a mathematical function, these neural nets can learn it. Except that you still need a lot of data to train them. Now the algorithm is there, the proof is there, but you now need the data and computer to actually train them. And that's where the AI winter started, because in those days there was no compute, there was not that much compute, there was not that much data, so nothing really happened. These things would have taken forever to train, etc. So nothing happened, the mathematical principle and proof were there. But then, and now I'm jumping to 2012s, before this, a lot of compute and data was started to become available. And I'll come to that in a moment. But the first breakthrough, at least from my point of view, when I got back into AI as a field is around 2012, 2013, when AlexNet, which is one of the, so this is only one part of my intelligence, which is visual perception. So AlexNet was able to distinguish images, so distinguish a cat from a dog at an accuracy better than humans. That's the threshold. Once it breaks is a real inflection point, right? It could do that in the past. 50% of the time you'll get it right. You'll say, okay, fine, that looks pretty cool, but I can't use that in my real world because the human is doing better. But now I've reached a stage where it's doing better than a human, distinguishing between a cat and a dog. So a cat might be hiding somewhere there, a human might miss it, but this machine will not. That happened around 2012, 2013, somewhere then, and that's where I actually got back into the whole field with fascination. But remember, it's all only one skill, which is visual perception. Then language breakthroughs started to came with Transformer. There were some other breakthroughs also happened in between, but interest of time, I'm not going through all of that. But Transformer then solved the language part. So it started to understand English, could translate that into French, and so on and so forth. Now that is another part of human skill that's kind of being solved, and at a level which is better than human, right? Better than most human, right? So I mean, obviously there are some humans who will be very exceptional at it, but 80% of the time, if I have to do English to French translation, these transformers could do it better. And then came large language models. So this is what you've been seeing now. This extended the language and the visual all the way to other things like creativity, reasoning, and so on. And this is what you observe when you use ChatGPT, right? I mean, I'm sure that when you use it, you realize that sometimes it can think, it can actually comprehend, it can really, and with the multimodal models. So I'll give an example that if I have a video where a truck is coming towards me, a old computer will have no understanding. It might tell you that there is visual perception, will tell you there's a truck, it's coming towards me, but that's it. So this large language model can do reasoning, right? Can think it's coming towards me, I'm in danger, I need to have a path. Now, obviously these machines can't run, but it can actually think that way. By the way, that's the whole concept of the self-driving cars, wherein they are trained to respond accordingly. Anyway, so large language models is where you actually started to solve all these other things, other skills that human have to opt, cognitive skills like reasoning, planning, comprehension, language. Now you could argue based on your own experience that it has solved it to some extent or some varying degree, and that opinion might differ. What's very hard to differ is the secular trend and the exponential growth here. What was there 2 years ago, it's at least 20 times better now. And again, people like me who are, who are kind of involved in depth in it, it's gonna get 10 times better in another year or so. And I think it's already there and thereabouts where it can do 90% of tasks better than 90% of the people in terms of the cognitive skills. Any questions, Bhavan? So that's why I say it's an inflection point, because by this point, which is around 2023, 24, is when we have solved the science of AI. Science meaning we've done the mathematics, we've made it work, we've demonstrated it works. From now on, it's about engineering it in our real world scenarios and scaling it. But that's a smaller problem. I mean, it's still a problem, but it's a smaller problem. Once I've done the science of it, once I know Pythagoras did the Pythagoras theorem, after that, it was just a case of implementing that in the building structures and so on. So similarly, now that we've done the science of it, now it's just about scaling and implementing in real world scenario, and that's what is unfolding now. And as it gets better and better, you'll see more and more disruption going on. So as I was referring to my previous slide, this chart kind of explained that what happened from 1980s to early 2010s. You can see that the availability of compute grew exponentially. So that was ingredient number one that happened after Geoffrey Hinton proposed backprop. And this is the availability of data, right? With the social media, with the internet, with the web, and so on, the data also exploded. So these two things merged, and these two things then allowed the training of the models to happen. And that is when 2010, 2012 onwards, AlexNet and the rest of the breakthroughs began to happen. So this is the story so far. Where do I at least feel things are going? So in 2025 is the part where we have built the foundation models. These are things like ChatGPT or Claude, llamas, or any other thing that you see these days. So these are the foundation models. Think of them as just brains, right? Right now in the chat box, they're just like head, wherein you ask a question and all it can do is to give you an answer. But that's because that's the form factor I've developed. But imagine that if I also, it's no longer a head, it's actually a body where I give it some tools, some digital tools, where it can actually not only just think, but tell my hands to do an action. Now that's what agentic AI is, wherein I give it some digital tools and say, think and perform that task. For example, I want to go to Washington, book me a ticket. In the past, it would only give me an answer, these are your possible options, but once I give it access to booking a ticket as well, or those tools to book the ticket, it can actually go ahead and book that ticket as well. I'm kind of doing some spoiler alert, but imagine I'm still using digital tools. Imagine a world where I can actually give it some physical tools as well. Let me just hold on to that thought. So this is foundation models. Agentic AI is what I explained. So in the beginning, it is just a brain that is available to me, but now it's a brain in a digital body, if you like. That's an agentic AI, and it's a big breakthrough. I mean, it's a bigger breakthrough than many of us might realize, because this is a time when I can actually, as a human, sit back, give it my intent, that it can actually go and do those tasks, digital tasks. But nevertheless, many of these tasks these days that we do are digital in nature. I don't know, you can think of a number of examples, including the examples that Sarang gave. Soon we would be thinking of AI native agent swarms. What that means is, now I'm still talking about an agent which listens to me or perform a task. Then soon there will be like multiple agents, like a swarm of agents, which can talk to each other, negotiate with each other, and actually perform much bigger, much wider set of tasks as well. Um, uh, I was thinking whether I should give a scary example or not, but let me just give. I mean, it's okay to give provocative example, right? Go ahead. So, for example, drones, right? So, I mean, imagine the drone swarms as with LLMs in them, and they can coordinate with each other and coordinate an attack, right? I mean, that's one extreme example that I'm giving. That's an example where I don't need a human to be in between, but these agents can talk to each other, negotiate with their own thinking. You can argue whether they think good or bad. I think they think as smart as many humans. The only thing is that they don't really have a motivation. That's one thing, by the way, that's lacking, the emotional part and the motivation part. They don't really have motivations to exist as such. Mathematically, though, that's not a constraint. I can build model that will have some motivations as well. But let me hold on to that thought as well. The way large language, maybe not relevant to this audience here, but this is basically where I take this model and apply it to very specific industry-based models, like in banking and other places. And that just means that they become even more smart, right? Some people might argue it doesn't work in this scenario. That's like if I take a Harvard graduate, right, or an Oxford graduate, and in the beginning I start to complain he doesn't know anything about banking, he doesn't know anything about my industry. Well, he would know it once you train him. Once he has spent some time and he understands your company, then his Harvard brain plus that knowledge becomes even more powerful. So that's something that'll start to emerge as well. But this is the key next frontier. I mean, some people are probably not even appreciating the current frontier that's happening, or current change that's happening. The other one is physical AI. So this is when I was saying that imagine I have a brain, but I have actually given it a physical tool. Let's say robots, right? So current robots, they don't think, right? They can perform actions, but they've been programmed to do something. For example, I'm programmed to pick up something and lift it, put it here. But that's still very mechanical. Imagine if you have a robot that can actually think like humans and then perform action. So they can think and perform those actions. And that's where you introduce a new physical Turing test. That is, let's say I had a party last night and in the morning everything is a mess. I go to work, I come back home, but everything is squeaky clean, right? But I can't make a distinction whether my maid came or my robot did it. That's your physical Turing test. I think that is likely to be achieved somewhere early 2030s, 2032, 2033. By the time some of these robots, by the way, are already out there. They're in China, in America, they're already there. But they're gonna get that good that you can't actually make a distinction between whether it was a human or so I think humanoids are probably the next largest economic disruption that might happen in future. Because a lot of people think, so this current disruption is about knowledge workers. Physical workers are gaining right now. Physical meaning those do physical job. But this is when that will begin to get disrupted as well. And then, since I'm from quantum as well, so and this is very relevant. But so by the time people figure out this whole AI and the rest of it, the quantum will also come. That will just take it to another level. This is another super computing platform where it will be able to solve problems that we can't solve today, or the problem that takes the age of the universe to solve, they'll be solved in the minutes. And once that comes, that's like being on a treadmill, right? Which is the incline, it continues to grow up, growing, and I'm trying to make myself adjusted to the growing incline, but at some point, I just, at least I feel exhausted. Yeah. Yeah, I think that's it. But this kind of puts a slightly different picture that right now, in terms of productivity, we are at a steeply exponential curve right now, which is why you hear all these noise in the markets, the labor disruption, and so on, which by the way is real. So right now, not much is happening because AI is working more like my teammate, right? The co-pilots and everything. I'm still there. I'm using it. AI is there as my co-pilot. But soon the agentic orchestration will start to come, and I also, as a human, my job will be to just stay on the side, maybe just keep an eye. The rest of the work will be performed by the AI agents put together, and that's already happening. Like those of you who do coding and if you use Claude and some other tools, it's just mind-bogglingly good, right? You just sit there and it does everything. Um, then multi-agent team. So right now it's about one team trying to do their work together, or maybe individuals. But then eventually your different department, your HR department, your finance department, they'll all start to coordinate with the agentic platform as well, and that's where the productivity will go even further up. And then eventually I get to intent-based enterprises, meaning as an enterprise, I just give my intent. I want to say that I want to launch this product. I want to do this particular thing. And all of that, it'll figure out, okay, I need to get HR for this, product manager for this, finance for this, and it'll orchestrate all of that. So all of this productivity, so this is not happening just now, obviously, but this is not happening just now, not because the science or the AI capability is not there. It's because companies are figuring it out, right? They are trying to implement it, and it'll take them some time, but they'll eventually get there. And then the robotics part as well. So once all of this happens, this is our steep exponential curve that we have.
So basically, that slide had details on how it can be used in the music industry specifically. So that was the whole intent of that particular slide. So some points in those were, see, as Tushar also explained, there is this concept of a large language models. These are vast sets of data accessible across the globe by everybody, and sometimes it is very useful. For example, in if you are generally searching in the Google or generally doing some activities, it might be very useful. But if you are specifically looking at a specific industry, like a banking or a healthcare or something, they like to have some focused set of data, right? They don't want this huge language model to be made available to them, which is first of all exposing a lot of information to your organization, as well as there is some security aspects to it. So there is something called as a RAG concept in AI, which is retrieval augmentation. What you do is in that you customize these entire LLMs or these large language models to a specific industry, for example, banking, or to a music industry, or to a healthcare industry. So specifically for the music industry, if you have a subset of that as a RAG, and these are something like SLM, that is small language models actually, which are more contextual to music industry. For example, Sarigama Padanisa. Those are something which are used in music industry, but not in the banking industry, for example. So all of such important ones which are required for the music industry, they can be encapsulated into this RAG system. When you have such a thing here, then what you can think of is a standard first example is there is a class happening, a music class or a dance class happening. It can help the students who did not join it with some AI based system, like Copilot or Gemini or whatever it is, can help you give a transcript of what has actually happened in the class, as well as kind of give you the video part of it as well, so that like you can go through. It's a typical recording which was there previously as a tape recorder. Instead, now it is actually summarizing also. It is not only just capturing that entire video, but summarizing as well on what has happened in the class. And these are useful even to the students as well as for the faculty or the teachers who are teaching. There are other scenarios where it can be beneficial as well. For example, like you can actually improvise on a lot of creative synthesizing using AI actually. So whatever are the normal what to say ragas and talas what we have in today's world, we can actually improvise on this using a lot of creative things which an AI system, for example, as we discussed the agentic AI part. if that can actually synthesize some new music that can be looked at by the teachers and try to see if they can try to utilize it or compose something using it and things like that. I'll come to the flip side of these. There are some flip sides of these as well, actually. So I'll come to that. And that is one way of looking at it. Creative music compositions, which can be looked at from here. Then there are other scenarios in the music and dance industry where it can be utilized for, say, for example, how to like what to say, uh, follow some instructions what the teacher is telling, and remotely trying to solve it at your home itself, actually. So yeah, a classic example of this will be, let me think what can be a scenario here. You can do some generative AI prompt studying of what the teacher has told, and then like do some prompt checks and see what the teacher was trying to tell. You can learn more in that whole process and go back to the next class with more details. This is a third kind of a scenario. Now there are some flip sides of these as well. See, one of the things is, while all this is actually a lot more on the positive side, there are copyright aspects which come into picture. So what happens is, like you train a particular model to actually learn a music, for example. Then it uses it to synthesize any new music. Then there is a copyright infringement aspect which you will have to take care of. Then there is an aspect of many in the music and cultural industry have a lot of fan bases, actually. So their emotions, actually, if at all an AI system is giving a reviews or feedbacks, which is probably good or not so good, we don't know how it is being going to be perceived by those fans. And in fact, that's sometimes been seen in the newspaper also as a dangerous things. People try to object to those feedbacks or reviews, and these are come into picture. Similarly, there is a lot of the AI systems can also kind of endlessly try to synthesize some things which might be more of a noise rather than music. So that part is also there. It can feel that it can keep on generating a lot of music, but that might be monotonous or repetitional, and it might be slowly turning out to be a noise rather than music. So some examples of these are the way we should be looking at in using in the music industry. I did have a lot more on the write up. It's there in the slides.
We can share the slides.
We can share the slides if you want with you on deep fakes. Yeah, I mean, yeah, there was aspects of like somebody trying to mimic somebody, for example. I mean, he's a very famous composition person, and he is being mimicked, actually. So these deepfakes, they float a lot around. So these are some of the con side of things. The pros are also there. The pros are a lot more. If you have it on yeah, maybe I'll take my wife's mobile because she has the PPT slide as well. I'll just share some more examples. And yeah, yeah. Automatic recording analysis, improved creativity, few operational aspects. For example, like yeah, this is an interesting scenario. If you have a large organization, a music and arts organization, you can eventually look at introducing a bot or a robo which takes any newcomer to take around the campus, show the various classes, and like explain what each class does, for example, and how is it going to be beneficial. So usually this is done by some of the facilitators, but this can be a repetitive work done by somebody. Not that we are taking somebody's job, but it can be a scenario. It's just a scenario of how it can be utilized. Yeah. All I'm telling is, again, as if you have been to the starting part of the thing, only the repetitive task which we want to use it. So if you really want, if there is a chief guest, for example, we don't want a bot to explain around it. You want a personal touch to it, and so that it is thoroughly explained. But if there are 100 people who are coming in a day, if the same person is going to be taking them all around campus, then there is a challenge for that person also. So it can help. Yeah, it can help that individual. That is one aspect. Yeah, creative synthesis of fusion forms we discussed. Create insights from various feedbacks from students. Yeah, this is something like it can be fed into some AI systems. Students usually sometimes they do tell the teachers, but sometimes they tend to not to convey a lot as well. They have their exams and they're busy and things like that. So they can use or feed into some AI systems as feedbacks, surveys. Then these insights can actually build the foundation for an improved system in the music industry itself. The drawbacks, as we talked about the drawbacks, copyright infringement, labeling of AI generated should be clear. Yeah, this is something what, as we were talking about deep fakes and all of those. If you are doing something out of the way, it should ideally be labeled as AI generated. These aspects should be taken care. Uh, Protecting the safety and personality. Personality safety is one thing, as we discussed actually. So that is one important thing. Human in the loop is a must, as he rightly pointed out as well. That it, for a emotional touch, especially music is all about emotions, and you need to have that human in the loop. But some things which can help ease out some of those tasks we should look at. Yeah, then yeah, and something so that it doesn't go out of the hands. Yeah, these were some points which were specific to the music industry. Now I think, as Meera told, we'll open up to any questions. Tushar and me are here, and we can answer any questions. Yeah.